children, welcome to Zero Panic Maths. In today's session, we are going to continue our discussion on the relationship between the zeros and coefficients of a polynomial. But before you start watching this video, I recommend you to watch the introductory video on Chapter 2 Polynomials, because in that session we have discussed the different types of polynomials, what is the zeros of a polynomial, and what are the degree of a polynomial. The knowledge in that video will definitely help you in understanding the concept that we are discussing in today's session. Okay, so let us continuing on the relationship between the zeros and the coefficients of a polynomial. So in the last session, as I already told you, we understood what is the zeros of a polynomial. Okay, and we know that what are the coefficients of a polynomial. Coefficients of a polynomial are actually the real numbers that appear along with the variables in the polynomial and also as a constant. Okay, now in the last session we have seen that the zero of a linear polynomial will be of the form ax plus b is always minus b by a, where minus b is actually the constant term, the minus of the constant term, and a is a coefficient of x, the variable term in that. Okay, we already know this. Now in this session we have to understand whether the same relationship between the zeros and the coefficients of a polynomial, the quadratic polynomial, whether it exists or not. Okay, to understand that concept, we need to first take an example of a quadratic polynomial and find out the factors of that polynomial, factorize that. Okay, what do you mean by factorization? Factorization is a method where we represent the given polynomial in terms of the variable in power x only. Okay, in power of 1. So if we are able to represent the given polynomial in the form of a product of some equations wherein the equations contain only the variable terms in power of 1. So all in all, actually we are finding out the factors of this given polynomial. Okay, what is the way to find out the factors of 2x square minus 8x plus 6, which is actually a quadratic polynomial, and that method of factorization is by splitting the middle term. Okay, so let us take this example and find out the factors of this. Okay, now given expression is 2x square minus 8x plus 6. Okay, let me split the middle term minus 8x as 2x square minus 8x. I'm going to split it as minus 6x minus 2x, and plus 6 I will write it as it is only. Okay, I did not alter anything in the given expression, given polynomial, but I just wrote minus 8x and in the split form minus 6x minus 2x is actually minus 8x only. Now why I am splitting this expression? Because I want some x terms to be taken as a common from the first two terms and the last two terms. Now the three term polynomial, now I've split it into a four term polynomial and taking some common between the first two terms and some common from the second two term, so that I'm left with only the variable in power of 1 only. Okay, you'll understand that why I'm doing that at the end. Okay, now what is common in 2x square minus 6x? It is x is one thing that is common, and among 2 and 6 there is 2 that also comes as a common part. Okay, so I will write 2x as common among the first two terms. Okay, listen carefully. If I take 2x as common from the first term, what remains inside the first term? It only is remained with x. You see that 2x into x, it becomes 2x square, and minus as it is. Okay, and from 6x I've taken x also as common, and I've taken 2 also common from 6. So assume that 6 I am writing it as 2 multiplied by 3, and from that 2 multiplied by 3 I've taken 2 outside. So what remained inside is only 3. Okay, now if you just multiply this 2x into x, 2x square minus 2x into 3, it is minus 6x. You understood this? Okay, now let us take something common out of the last two terms also. So what is that is common that I can take? So x is not there at the last term, so I can take only the constant as a common, and let me take minus 2 as a common thing out of the last two terms. So what remains in minus 2x? If I take minus 2 outside, it is only remain with x. And out of plus 6, if I am taking minus 6 outside, it will be again remain with minus 3. Now why minus 3? Because if you see minus 2 into minus 3, it will become plus 6. And minus 2 into x, it will become minus 2x. Okay, understood this step? Okay, now let us now take something again common from the given expression. Now you can observe one more thing. After taking out the commons, this expression is now of only two terms separated by minus. So there are only two terms, 2x into x minus 3 and minus 2 into x minus 3. Now if you observe clearly here, okay, there is something common out of this expression also. And what is that common? Common is x minus 3, x minus 3. Now if I take x minus 3 outside, what remains inside is 2x minus 2. Okay, let me take x minus 3 outside, x minus 3 outside. Now if I take x minus 3 from this expression, considering this as one expression, okay, sorry, considering this as one expression, if I take x minus 3 outside, what remains in the first term is actually 2x, and what remains in the second term is minus 2. Okay, now something is common here also, 2x minus 2, so 2 is also common. I can take 2 also common, and finally I can write it as 2 into x minus 3, and if I take 2 common from here, it is x minus 1. So this is actually the factorized form of 2x square minus 8x plus 6. Now why we have done the factorization of this given polynomial is because if I equate this part or this part to 0, it will actually give me the zeros of this given polynomial. Okay, so suppose now what value or what action makes the whole expression, the last expression, as 0? If x minus 3 becomes 0, the whole expression becomes 0. If 2x minus 1 becomes 0, then the whole expression becomes 0. So those are actually the zeros of this given polynomial. So I can take, therefore, x minus 3 is equal to 0 is one factor of this, and x minus 1 is equal to 0 is another factor of this. So either x can be, if x minus 1 is equal to 0, x can be either 3 or x can be either 1. So there are the two zeros, x is equal to 3 and x is equal to 1 of this given polynomial, given quadratic polynomial 2x square minus 8x plus 6. Understood this clearly? Now after finding out the zeros of a polynomial, now you have to define what is the relationship between these two given zeros and the coefficients of this expression 2x square minus 8x plus 6. Okay, now let us write that observation. Okay, the right side part. Okay, let me write 2x square minus 8x plus 6. So if you equate this equation to ax square minus bx plus c, which is the generic form of a quadratic equation, if I am writing this as ax square plus bx plus c, then I'm going to get what is a is 2, what is b is minus 8, what is C is actually 6. Okay, now let us verify. Now you see that sum of its zeros, one observation that we can make. What are the zeros? 1 and 3. If you sum up 1 and 3, you will get 4. If 4, I am writing it as minus of minus 8, minus of minus will actually make it is 8, 8 by 2, which is 4. So nothing I am doing, I am just converting that 4 into a form wherein I can write that into a in the form of a coefficients of the given expression. So 4 I am writing it as minus of minus, which is actually plus only, plus 8 by 2, which is actually 4. Okay, understood. Okay, now minus, I am keeping minus as it is. Minus 8, what is minus 8? It is B, so it is B. What is 2? 2 is actually A. Okay, so it is minus B by A. So what is the relationship here? In quadratic polynomial, the sum of its zeros is always equal to minus B by A. And what is minus B? Minus B is actually, or B is actually the coefficient of X. You can see that B is actually coefficient of X. So in generally, I can write minus coefficient of X divided by coefficient of X square. That is A. Coefficient of X is A. Okay. Now this is about sum of the zeros. Now if you multiply the two zeros, what happens? That is product of its zeros. It is 1 multiplied by 3. Again 3 I am writing it as 6 by 2 only to convert that format into the way that I can represent it in the form of a coefficients of that quadratic polynomial. So 6, since 6 is a constant term, the last term in the quadratic polynomial, and A is actually 2, and that 2 is the coefficient of X square. So what is product of the quadratic polynomial? Product of zeros of a quadratic polynomial is actually C by A, which is constant term divided by coefficient of X square. This is all about the zeros, the relationship between the zeros and coefficients of a quadratic polynomial. So now we have understood what is the relationship for uh, the linear polynomial and a quadratic polynomial. Okay, okay, now let us move to the next session. Now let us verify the same thing with another example. Okay, okay, now in the previous slide I actually splitted minus 8 into minus 6 x and minus 2x. So how did I went to that factorization or splitting that middle term directly? I will give you a simple hint here. Okay, so when a quadratic polynomial is given, listen carefully, when a quadratic polynomial is given, always take the product of first and the last term. So what is the product of first and last term? First term, that is actually a x square term. It is 3x square minus 2. Along with signs only you have to take. Okay, remember that. Along with signs, you have to multiply the first term and the constant term. Okay, that is first thing. So what is that? Minus 2, 3, minus 6 x square. Minus 6 x square is one term. Keep this it in your mind. Okay, and what is the middle term? 5x. What is the middle term? 5x. Now given minus 6x square and 5x, you have to split or you have to find out the two terms wherein the sum of the two terms comes as 5x, that is middle term, and multiplication comes as the product of the first and the constant term. Now I'll give you that terms. Okay, 6x is one term and minus x is another term. Okay, now you see that 6x minus x, what it will be? If you multiply that, it will be minus 6x square. And 6x, if you sum up 6x minus x, what will be? What it will be? It will be plus 5x. Understood this concept? Okay, so this is the way that you have to split the middle term. Okay, let us do that. Okay, now 3x square plus 6x minus 1x and minus 2. I'll keep it as it is. Okay, you see that 6x minus x is always 5x. And first and last term, I've not altered it. Okay, but followed this logic. Remember that logic. Okay, let us keep that. Okay, now take common out of the first two terms and common out of the last two terms, if at all there is common thing. Okay, now again you can see that x is common, and between 3 and 6, if I'm writing 6 as 3 multiplied by 2, 3 again comes as a common thing from here. So 3x is common. So from the first two term, it is the x term that remains, 3x into x square, plus x is already coming as a common thing, and then out of 6 I am remained with plus 2. 3x into 2, it is plus 6x. So it is already x minus 2 here, so there is nothing common except the term 1. So I am taking minus 1 as common here, so that I am remained with x plus 2 inside it. So you see that minus, why I have taken minus 1, because minus 1 into x, minus 1 into plus 2, it is minus 2. And also I am making the last term as similar to the first common term here in the left hand side, because I want in the next step I want that term to be taken out. So you keep that also in mind, that you have to take the common thing out of the last two terms in such a way that you will achieve the common here, so that in the next term, next step, we will take that as a common. Okay, so x plus 2, again this is one term and this is another term, so I'm taking x plus 2 common here, x plus 2 as common. And then next, what remains in the first term? If I'm taking x plus 2 as common, it is remained with 3x, and in the second term it is remaining with minus 1. Understood? Okay, now this is what the factorization of 3x square plus 5x minus 2. Okay, now to make this equation, or to find out the zeros of this polynomial, I should be making this also, this as 0 and this as 0. So if I'm saying, therefore if x plus 2 is equal to 0, then x is equal to minus 2 is 1 root or 1 0 of this polynomial, and the second term 3x minus 1, if I'm making or equating that to 0, then I'm remained with x is equal to minus 1 goes to that side 1, and 3 goes to that side, will make it 1 by 3. So these are the two zeros of this quadratic polynomial, 3x square plus 5x minus 2. So now let us verify the same thing here also. Minus 2 is 1 and 1 by 3 as another 0 of this. I'm summing up that. So sum should actually come to the value which is equal to minus b by a. Okay, so if I'm taking minus 2 this way, so cross multiplication, I'm taking the LCM and making the cross multiplication. Okay, so 3 it comes up to minus 6. It is like this. If you are getting confused, I'm taking 3 as common here, sorry, 3 in the denominator, and making 1 3s are, and it is minus 6. Okay, 3 1s are, I'm taking the LCM, simple thing. Okay, so it is, so what is 1 minus 6? It is minus 5. It is minus 5 by 3. And what is minus 5? It is actually minus b. What is b here? If you write 3x square, sorry, 3x square plus 5x minus 2 as the equation, then this is a, this is b, this is c. Let me write it here, a, b, c. Okay, so it is actually minus of b is 5 and a is 3, coefficient of x square. So the observation is correct. Okay, now if I multiply product, okay, so minus 2 multiplied by 1 by 3, which is equal to minus 2 by 3. Okay, what is minus 2? Minus 2 is C. What is 3? 3 is A. So we have proved that our observation that if you sum up the given two zeros of a quadratic polynomial, then that sum will be always minus b by a. If you multiply, that product will be always equal to c by a. Hope you understood this concept clearly. Okay, let us move to the next session. Okay, in this section we are actually going to prove this quadratic polynomial and the relationship between the zeros and the coefficients of the quadratic polynomial in general. Okay, we have seen two examples in the previous slides, but you may ask me that maybe for those two examples it might be working. How can we say that it will work for all the given quadratic polynomials? So in general, whether it works or not, we will prove that also. So generally we will identify. Okay, now what is given? Generally, if there are two zeros of a quadratic polynomial, let us call them as one as alpha and another as beta. So alpha and beta are the zeros of a quadratic polynomial, and what is the quadratic polynomial given is this ax square plus bx plus c. Then x minus alpha is one factor and x minus beta is another factor. Now why I'm taking minus? Because when I equate x minus alpha is equal to 0, then alpha x is equal to alpha is one factor and x is equal to beta is another 0 of that polynomial. So we are considering x minus alpha and x minus beta are the factors of p of x. Then in general, ax square plus bx plus c, we will resolve that first. Okay, now since we are saying that x minus alpha and x minus beta are the two factors of that, I can write this as k, where k is any real number, k multiplied by, since we are saying these are the two factors, I can directly equate this equation to alpha minus, sorry, not alpha, x minus alpha, x minus alpha into x minus beta. Okay, so just let me go to the previous slide. See, now why I'm writing that? Because see, this is the given expression. Okay, and finally what did we achieved is these are the two factors. So this is actually equal to this. So these are the factors. These are the two factors of this equation. So in the here they have given that x minus alpha and x minus beta are the factors of ax square plus bx plus c. That's why I've written, in place of that I've written it. And what is k? K is any real number, because we have to prove that in general that for any real number k, this will always work. Okay, now let us extend this. Okay, k, inside k, x into x minus beta minus alpha into x minus beta. Okay, now let us resolve the expression inside this, keeping k as it is. X into x, x square, x into beta, it is minus x beta, alpha into x, that is minus x alpha. Okay, minus alpha into minus beta, which is actually plus alpha multiplied by beta. So that is inside this. Okay, now writing k as it is, x square minus, now if I am taking minus x as common from these two terms, then minus x. Okay, and taking the common x, it remains with beta plus alpha inside it. I can write that as alpha plus beta. Okay, you can see that minus x alpha, it is minus x alpha, minus x beta, it is minus x beta. Okay, and finally I'll write alpha beta as it is. Okay, Now multiply this k real number into every term. Okay, now it is k into x square minus k x into alpha plus beta, or simply I can write k alpha plus beta first, and then I will write x. It is actually, I'm just taking x to that side just to represent that in the form of ax square plus bx plus c. Now let us see what minus b by a and c by a gives us. Okay, now if I am equating this to ax square bx plus c, then what is b here? What is b? That is minus k into alpha plus x. And what is c? K alpha beta. And what is a? Is actually k. Okay, so therefore if I am equating this to ax square plus bx plus c, then I'm going to get a is equal to k, okay, and b is equal to minus k alpha plus beta, okay, and what is c? C is equal to k alpha plus beta, sorry, k alpha into beta. Okay, now if I am taking minus b by a, now what happens if I take minus b by a here? Minus b by a, which is actually the sum of the two zeros of the given polynomial. Okay, minus b by a. What is minus b? It is minus of minus k alpha plus b. Okay, minus of minus k alpha plus beta. Okay, listen to me carefully. And what is a? A is actually k. So minus of minus will actually become plus, then k get cancels. What remains is alpha plus beta. So what do you mean by that? What are alpha and beta? Alpha and beta are actually the two zeros of a quadratic polynomial. So, and what is that is equal to alpha plus beta is equal to minus b by a. So minus b by a always represents the sum of the two zeros of this quadratic polynomial. Similarly, if I am taking c by a, see, c is k alpha beta, then k get cancelled. So I can even take this here itself. Here itself, I can write what is C? What is C? K alpha beta. K alpha beta. And what is A? Is K. K cancels. And what remains is alpha beta. Alpha beta is actually the product of the two given zeros. You understood this concept? In general, what we proved is sum of the two zeros alpha plus beta is always minus b by a, which is actually minus coefficient of x and coefficient of x square, and product of two zeros alpha plus beta for any given polynomial is always c by a, that is actually equal to constant term divided by coefficient of x square. Understood this? Okay, let us look at some of the examples and verify whether the relationship that we found out is correct or not. Okay, let us take an example. Find the zeros of a quadratic polynomial. Given polynomial, we need to find out the zeros of that and then verify the relationship between the zeros and the coefficients. Let us quickly find out the zeros first. So what is the given equation? X square plus 7x plus 10. So how do we split the middle term? We have to split the middle term to find out the factors of this first. So first of all, x square and 10, the product should be 10x square for us, and the sum should be the middle term always. Okay, so 7x should be the sum. We have to split the middle term in such a way that the sum will come up to 7x and product will come up to 10x square, and that term that I'll give you is 2x and 5x. You see that 2 into 5, 10, x into x, x square. 2x plus 5x is 7x. Okay, done. Okay, let us move forward. let us split the middle term as x square plus 2x plus 5x plus 10. Okay, so what is common from the first two term? X is common, only x is common. Okay, what remains inside this? X. What remains here in this term is 2. Okay, what is common between the last two terms is 5. If I'm taking 5, x remains in the third term, and the last term only 5 into 2, it is 2, which makes the x plus 2 as the common term in the extended expression. So we'll take x plus 2 as common, and x plus 5 is what remains inside. It is x in the first term and 5 in the last term. So therefore x is equal to minus 2 and x is equal to minus 5 are the two zeros of this equation. So if these are the two zeros, we need to find out whether the sum of these two zeros is minus b by a and product of these two zeros is c by a. Okay, so let me write what is a. A is 1 because the coefficient of x square is 1. What is b? The coefficient of x, that is 7. What is c? That is the constant term 10. Okay, now what are the zeros? Minus 2 and minus 5. Let us first sum. Let us first sum the two zeros of the polynomial. Minus 2 plus of minus 5. We are actually summing up this. Okay, what is that? Minus 2 minus 5, which is equal to minus 7. Minus 7, I can write it as minus 7 by 1 also. Okay, the denominator 1. So what is minus 7? 7 is b, and keeping minus common, what is 7? Is b. What is 1? Is actually a. So one thing is proved, that the sum of the zeros is minus b by a. Similarly, product. Similarly, verify the product also. What is product? Minus 2 into minus 5. What is minus 2 into minus 5? It is plus 10. 10 I can write it as 10 by 1. And what is 10? 10 is c. And what is 1? 1 is a. So c by a. The second verification, that the product of the two zeros is always c by a. This is a very simple example. Okay, let us see the next example. So here the next example is little bit different, because the given quadratic polynomial does not contain the middle term itself. Okay, till now what did we do is splitting the middle term, we found out the factors of the given quadratic polynomial. But if there is no middle term at all, then how do you find out the factors of that? Okay, so there is a simple algebraic trick for that. You know one formula: a square minus b square is equal to a minus b and a plus b. You know this algebraic formula that you have studied in your previous, either in 8th or 9th, you might have studied this. A square minus b square is equal to a minus b, a plus b. Okay, so this given expression is actually in that format only. Okay, how it is, it satisfies this algebraic formula. Let us see that. What is the expression given? X square minus 3. Okay, now if you see 3 is not in the form of b square, but I can just modify 3 into the form of b square. How we are modifying that? X square minus, I can write 3 as square root of 3 and whole square. Now, why did we write 3 as square root of 3 whole square? Because we are not altering the value 3, because square and square root get cancels and 3 remains. But what is that helping us is making the given expression that actually satisfies a square minus b square, where a is x and b is root 3. b is root 3 and we are making b square out of it. So by the algebraic formula, a square minus b square is always a minus b and a plus b. That actually gives us the factors of this expression directly. Okay, simple, very simple. So a square minus b square, what is a? X, minus what is b? Root 3. Correct? Okay, what is the second factor? A plus b, what is a? X. What is b? Square root of 3. So this is actually in very 2 steps we have found out the factors of x square minus 3. And what are those 2 factors, or what are the zeros of this? So if this is one factor, this is one factor, then making x minus 3 x minus square root of 3 is equal to 0 makes x is equal to square root of 3 as 1 0. Okay, and x plus square root of 3 making it to 0 will actually give us the another 0 as square root minus square root of 3. So square root of plus square root of 3 and minus square root of 3 are the 2 zeros of this equation. Now we have to actually verify that whether sum of these 2 zeros will give us minus b by a and product of these 2 zeros will give us c by a. Let us verify that. But before verifying that, let us write the given quadratic equation. What is a here? A is the coefficient of x, which is 1. What is b? Because there is no term with x, b is 0. And what is c? The constant term minus 3. Okay, remember that you need to consider the values of the coefficients and the constant terms along with signs. Okay, remember this part first. Okay, now let us sum up the 2 zeros of this polynomial. What is first 0 plus root 3 minus root 3? What is this? 0. Okay, 0 is actually b. And what is a? A is 1. So 0 by 1, it is actually making the first verification that sum of the 2 zeros is minus b by a. So making 0 with minus or plus does not make any difference. So it is actually 0 by 1. So there is no term b only. So we are equating that to minus b by a. You can even say this as 1 because 1 is a. Now multiply product. Okay, verifying the second thing, that product comes up to c by a. So minus into plus, that is actually minus root 3 into root 3, that is square root of root 3 square. Now as I already told you, square and square root get cancels. What remained is minus 3, and what is minus 3 is actually c. Correct? Minus 3 is actually c. And what is a? A is minus 3 by 1, c by a. So let's move to the next example. Okay, here this example is little bit different from the previous 2 examples because we are not given with the quadratic polynomial here, but the reverse way, we are given with the sum of the 2 zeros and the product of the 2 zeros. We have to find out the quadratic polynomial only. Okay, by the knowledge that what we have discussed till now. See, what they are asking here is find a quadratic polynomial. Polynomial only we have to find out, and what is given? Sum and product of whose zeros are, sum is minus 3 and product is 2. Okay, so suppose, let us start with the solution without wasting time. Solution: suppose alpha and beta, let us take alpha and beta only. Suppose alpha and beta are zeros of the polynomial. We don't know what is the polynomial, but we are saying that alpha and beta are the zeros of that polynomial. But what is given? What is given is sum is minus 3 by a. So therefore alpha plus beta is equal to minus 3. Okay, and alpha multiplied by beta is equal to 3. That is what is given here. Okay, so 3, since we know that alpha plus beta, which is sum of zeros, is always minus b by a. We know that, correct? Okay, so if I'm writing minus 3 as minus 3 by 1 and 2 as 2 by 1, which does not make any difference. So if equating minus 3 to minus b by a, because we know that alpha plus beta sum of the zeros is minus b by a. So what does it gives us? B is equal to 3 and a is equal to 1, correct? A is equal to 1. Simple. Okay, now by this also, what is this? Product of the two zeros is always c by a, correct? So by this also we found out the value of c, and that is equal to 2, and a we have already found out that a is equal to 1. Now we found out with the given alpha beta and sum of alpha beta minus 3 and product of alpha beta as 2, we have found out what is a, what is b, and what is c. What do we need is the quadratic polynomial containing the coefficients as a is equal to 1, b is equal to 3, and c is equal to 2. Simple. Okay, so therefore the quadratic polynomial, or I can simply say the polynomial, is ax square. What is a? 1. So 1x square, ax square plus bx. What is b? 3. That is bx plus c. What is c? 2. Okay, simple. So this is that polynomial that actually gives us sum of the zeros as minus 3 and 2 as the product of zeros. This is not the only quadratic polynomial that actually satisfies this. We have to, there are some more polynomials that can actually satisfy the given equation, because this is one quadratic polynomial that will actually satisfy that. So in generally, the other quadratic polynomial that fits the same condition is this polynomial with any real number k always gives us this condition to be satisfied. So other quadratic polynomial that fits this condition will be of the form k, and this equation, the equation that we found out is x square plus 3x plus 2, where k is real. Okay, where k is real. K is any real. For any real value k, we can actually get such result. You can even find out the example. Say for example, k is equal to 2, the equation will be 2x square plus 6x plus 4. If you resolve the equation 2x square, taking k as 2, 2x square plus 6x plus 4, if you resolve this equation and find out the zeros, then sum of the zeros will actually come up to minus 3, and product of those two zeros will actually come up to 2. So for any given k real value, this is the you will find out one more polynomial that actually satisfies this condition. So in generally, we have proved that there are so many such polynomials that can be formed by the given condition. Okay, understood this? Okay, okay, now let us move to the now let us stop our discussion here only, and in the next session we will see whether the relationship between the coefficients and the zeros of a polynomial, that what we have discussed for quadratic polynomial, whether it also works for the cubic polynomial. Okay, that we will discuss in the next session. Thank you.